So today we'll talk about linear equations and the equations of Bernoulli and how to solve this kind of differential equation. Firstly, let's consider definition of linear equations. So if we have first order differential equation of this form, or if we can write first order differential equation in this form, we say that this differential equation is a linear differential equation in the variable y. Okay, so if we have this kind of differential equation, if we divide this differential equation by a1x, we can obtain differential equation in this form, and we just define a0 over a1x as px and g at x over a1x as f at x. We call this form is standard form of first order differential equation. For example, we have first order differential equation, and this differential equation is linear differential equation because here we have, instead of a1x we have x, and instead of a0x we have x plus 1, and instead of g at x we have just x of power 3. So to obtain standard form, we just divide this differential equation by x, and we have here will be dy over dx plus 1 over x multiplied by y is equal to x squared. Okay, next one is how we solve this kind of differential equations. Firstly, if we have linear differential equation, we need to write this differential equation in standard form. As we know, standard form is differential equation in this form, dy over dx plus pxy is equal to qx. So, and the solution of this differential equation will be this function. Here we have y is equal to e of power minus integral of this px by x, and multiply by integral e of power without here sign, integral px dx multiplied by qx dx plus c. So this function will be a solution of linear differential equation. Let's consider example.
For example, let's solve this differential equation, and we see that this differential equation in standard form, instead of y, here we have what? Here we have, instead of y, we have here v variable. Our v dependent variable will be v. So in general case, if you have standard form dy over dx plus pxy is equal to qx, then solution of this differential equation we write in this form: y is equal to e of power minus integral px dx multiplied by integral e of power integral px dx multiplied by qx dx plus c. So let's write solution for this differential equation, and in our case, instead of here px we put what? Also px. Here will be our px is equal to minus 2, and instead of qx we have minus 2x, and instead of y we write here just v. Let's find integral of px. What will be integral of px? So integral of px dx is equal to what? We know that px in our case is equal to, let's write here, px is equal to minus 2, and qx here is equal to minus 2x. So integral of, we put instead of px minus 2 and dx. This one is equal to, we know that, minus 2x. Okay, so we write here v. So since instead of y we put v, here will be v is equal to e of power minus, here we put minus, and the integral of px, and we just put instead of px just minus 2x because we already found its integral, and we write here multiplied by minus 2x. Here we have bracket, and again integral of what? Again integral of px. So but here without sign, minus, and we just write here integral of px dx is equal to minus 2x. Okay, so multiply by this one by qx in our case is equal to minus 2x, so we write here minus 2x dx. Okay, plus c. So this one will be solution of our differential equation, but here firstly we need to find integral. What will be integral of this function? Let's write here integral e minus 2x multiplied by minus 2x dx is equal to what? Let's use here integration by part. So you can write this one in this form. Minus 2 integral x e of power minus 2x dx. So since you have here x and e of power minus 2x, by integration part you need to find derivative of this one. Derivative of x is 1 and the derivative of constant number is 0, and you need to find from the right side integral of this. Here will be minus 1 over 2 e minus 2x, and again integral will be just 1 over 4 e minus 2x. Okay, so integral of this function is equal, we multiply this one by x, so here will be with sign plus 1, and here we multiply this one by sign minus. Okay, we write here minus 2 integral of x e of power minus 2x is equal to minus 1 over 2 x e of power minus 2x and minus 1 over 4 e of power minus 2x. Okay, this one is equal to what? So right here equal to if we multiply minus 2 by 1 over 2, we have just 1, so here we have x e of power 2x, and the minus 2 will be here plus 1 over 4 e of power minus 2x. Okay, now we found integral of this one, and we can write here. So this one is equal to what? So we write here e of power just 2x, and in brackets we have this one x e of power minus 2x, and here will be plus 1 over 4 e minus 2x, and here plus c. So okay, this one is equal to what? We just open brackets, and here we have e of power 2x multiplied by e of power minus 2x, we have just x, and here will be plus 1 over 4 plus e of power 2x multiplied by c. So our v is equal to this function. And now we found our solution of this differential equation.
Next type of first order differential equation is Bernoulli. So an equation in the form dy over dx plus pxy is equal to qx multiplied by y of power n is called a Bernoulli differential equation. How we solve this kind of differential equations? To solve Bernoulli differential equation, we use this theorem. Here theorem says that suppose that n is not equal to 0 or 1, then the transformation v is equal to y1 minus n reduces the Bernoulli equation to a linear equation in v. It means that by changing y of power 1 minus n by v, we can reduce this differential equation to a linear differential equation. So let's prove this one. So firstly, we just divide Bernoulli equation by y of power minus n. So since here we have y of power n, this one cancels, and here will just qx, and here since we have just y, and here will be y of power 1 minus n, and here we have just y of power minus n dy over dx. So we change v as y of power 1 minus n, and if we find derivative of v, we have dv over dx is equal to derivative of this one, 1 minus n, and here will be just y of power minus n dy over dx. Here instead of y minus n dy over dx, we just put dv over dx and 1 over 1 minus n, and instead of y of power 1 minus n, we just put v, and here we have 1 over 1 minus n dv over dx plus pxv is equal to qx. If we multiply this differential equation by 1 minus n, we have dv over dx plus 1 minus n pxv is equal to 1 minus n qx. So if we define this one as p1x and this one as q1x, we can write this differential equation in this form: dv over dx plus p1x v is equal to q1x. So as we see, this one is linear differential equation, and here independent variable x and dependent variable v. So let's consider example. So for example, we have this differential equation, and this one is Bernoulli differential equation, and here n is equal to 3. Firstly, we multiply to this differential equation y of power minus 3, and if we multiply here y of power minus 3, here will be just 1, and we have just x, and here will be 1 minus 3, and here will be y of power minus 2, and here we have just y of power minus 3. Since v is equal to y of power 1 minus n, and n here is equal to 3, and here will be v is equal to y of power minus 2, and we found derivative of this one, and we know that derivative of this function is equal to minus 2 y of power minus 3 dy over dx. And we put instead of this one, this part, and of course here this comes to 1 over minus 2, and instead of this one we write dv over dx plus, here will be what? Since here v is equal to y of power minus 2, we just write here v, and this one is equal to x. So if we multiply this one by minus 2, we have dv over dx minus 2v is equal to minus 2x. Okay, before, when we considered example for linear differential equation, we solved this differential equation. So this one, solution of this differential equation was this function v is equal to x plus 1 over 4 plus e of power 2x multiplied by c. But in our case here, we need to give solution in variables y. So when we obtain solution from this differential equation, instead of v, we need to put y of power minus 2. So at the end here, we need to write instead of v, we need to write y of power minus 2. Here will be 1 over y squared is equal to x plus 1 over 4. Here will be e of power 2x multiplied by c. So we write here y is equal to x 1 over 4 plus e of power 2x c, and here should be y of power minus 2. If you want to find from here y, you need to just write root here 1 over x minus 1 over 4 plus e of power 2x c. Sorry, here solution was with plus. So we just write our solution in this form. Now we found solution of this differential equation. That's all.